I froze again. I'm sorry. This is not my fault. Anyways, I don't know where it got cut off. So since this is already solved for x equals 0, there was actually no work to do there. So you solve now x plus 8 equals 0. It just becomes a baby balancing problem. Circle the fence. Circle the variable, draw the fence. Subtract 8. So you have x equals negative 8. So the two roots to this equation are x equals 0 and x equals negative 8, which means if I multiply this out, if I get x squared plus 8x equals 0, I could graph that, find the axis of symmetry, get that, plug that in, get your vertex, find your values of x and y, but your parabola is going to cross at 0 and negative 8. So it actually shifted over, okay? And that's what that means. This is where your parabola is crossing the x-axis. I'm going to ask that a lot. But it's pretty straightforward on how you actually solve by factoring, which I'm kind of glad that I got this out of order by accident, because then I could work with you guys on 9.1 in class instead of having to watch this video. And I hope I don't freeze again. And then you'll see something like the quantity x plus 6 times the quantity x plus 5 equals 0. So I'm just kind of looking at some problems here. Okay, so you're going to set both polynomials equal to 0. So you have x plus 6 equals 0, x plus 5 equals 0, and then solve for x in both. Draw fence, circle the variable, subtract 6. Do the same thing over here, except for subtract 5. So you have x equals negative 6, and x equals negative 5. So this problem is already in factored form, because if we wanted to, we could multiply this out and get your polynomial of x squared plus 11x plus 30. Well, if we wanted to solve it, then we'd actually have to factor it back out and then set it to 0. Okay. So when you have your problem is set up already as factored form, straightforward, set both polynomials equal to 0 and solve. Remember, this is where your parabola is crossing the x-axis. Okay. Next up, we're going to do some problems. This is going to be NIB, so not in book. Okay, so we're going to still solve. Okay, and I got to go through and get some problems here. Or I can create off the top of my head. Okay, so let's go. X squared minus 6x plus 5 equals 0. Sometimes you see it like this when it's already in standard form, and so you have to factor and then balance and solve. Okay. So this is standard form, that's factored form. So the first thing you have to do is factor. There we go. So it's a good review. Okay. So remember, a times c is at the top, so that's 1 times 5, which is 5. B at the bottom, which is negative 6. AX up top left, top right. And now you're going to come up with the factors of positive 5 that add up to negative 6. So thinking about sign patterns. Since C is positive and B is negative, that tells you your factors, both of them are going to be negative. So you have negative 5, negative 1. Okay. These are your binomials. Set these guys equal to 0. So you have x minus 5 and x minus 1 equals 0. So we go from standard form into factored form. And then break them up. Whoops. Standard form, factored form. Both set equal to 0. Okay, this is your 0 product property. Ready to go. Balance and solve. And hopefully you got x equals 5 and x equals 1. So your parabola, you're going to have a linear term in this. See, because remember that thing shifts it over to the left or the right. And your u, it's opening up because a is positive, is crossing at 5 and 1. I like solving by factoring. I think maybe because we spend so much time on factoring, so I think it becomes a little bit easier to work on this method. People may disagree with me. I don't know. Let's see. Okay. I just have to pull up some more problems because our book does not do a good example about giving you, is not a good example, pardon me, of giving you good problems of factored form and standard form. So I gotta go elsewhere for some of these. Okay, so let's go. We're still solving. It's still example 2. 3x squared minus 14x plus 8 equals 0. So we're going to solve this, meaning we're going to find the possible 2 answers, possible because the next part's coming up, of where your problem is crossing the x-axis. Okay, standard form. Now we have to go to factored form, so let's factor this guy. So just double check. Oh, C is positive, B is negative, so that means your factors are negative again. I didn't mean to do that, but that's all right. So 8 times C at the top, 3 times 8 is 24. B at the bottom. And then don't forget AX on both the top, left, and right. So now you got to come up with factors of 24 that add up to negative 14. They're both going to be negative. So, 1 and 24, 2 and 12, 3 and 8, 4 and 6. That's it. So 1 and 24, no matter what we do with our signs, not going to get us negative 14. But we already know that both factors are negative. 2 and 12? If they're both negative, that will get us a sum of negative 14. This would be close. This would be a negative 11 right here. So that's why I like to write my factors out. Not everyone does, which is fine, but this just allows me to make sure I have all my pairs of factors, but then I can also write out the sums next to it. Okay, now, remember you're looking to simplify. Some of you guys weren't doing this last chapter. You're looking to see if you can simplify these guys. And so 3x minus 2 is good to go because nothing goes into 3 and 2 other than 1. So it's already simplified. So let's simplify 3 and 12. So 3 goes into both, 1 up top and 4 on the bottom. So we have x minus 4 and 3x minus 2 equals 0. Standard form and went to factored form. Now we're going to set both of these guys equal to 0. I don't know if I should watch this because I'm making so many just blah, blah, blahs today. Here we go. X minus 4 equals 0 and 3x minus 2 equals 0. Balance and solve. So when you have these, your A and B as your factors from your zero product property, it's either going to be a one-step equation like this or it's going to be 2. That's it. You're not going to have any more steps than that. So you're only going maximum 2, which means you're going to either add or subtract first and then multiply or divide, or just add and subtract. So here we go. Add 4 to both sides. Hopefully you guys are already doing this. And then over here, this is going to be your 2 steps. So you're going to add 2 to both sides. Sorry. 3x equals 2. And then divide by 3. X equals 2/3. Okay. So these are your roots, meaning these are the 2 x-intercepts, also known as the 2 answers that make this, there you go, that quadratic true. So quadratics sometimes have 2 answers. Sometimes they only have 1. We good? So sometimes they have 1. I'm going to show you what that looks like. Pulling up problems again. Okay. N squared plus 8n plus 16 equals 0. So example 2, everything is already in standard form, and we have to factor in order to solve. Example 1, everything was already in factored form, and so all we had to do is just set both equal to 0, and then we can solve. So standard form, let's go to factored form, and I hope I don't freeze. It was doing weird stuff again. Okay, here we go. Factor it. A times C at the top, B at the bottom. AX up top, And then factors of 16 that add up to 8. And C is positive, B is positive. So that means both factors are positive. So 1 and 16, 2 and 8, 4 and 4. Those are your factors of 16. We have 4. So we have n plus 4 squared. Okay. Now, you can do this a couple different ways. You can, instead of squaring the binomial automatically, you can just go n plus 4 equals 0 and n plus 4 equals 0. It doesn't matter. I'm going to show you this way first so you can see what it looks like, because this is going to help us for another method later this chapter. So if I want to undo this square, I'm going to take the square root. And so I have the quantity n plus 4 equals, and the square root of 0, 0. Well, now we have n plus 4 equals 0. And just balance and solve that. So we have n equals negative 4. Some of you guys might be saying, well, wait a minute, what happened to the other binomial? How come we're supposed to have two? We're supposed to have A and B, because the zero product property says A times B equals 0. So either A is B, or A is 0, pardon me, or B is 0. So this is one way of showing it. Here's the other way. If you would have, big fat or, if you would have just written this out as n plus 4 and n plus 4 equals 0, you'd set both equal to 0. But if you haven't caught on yet, it's the same exact binomial. It's n plus 4 is still the same as n plus 4. So subtract 4. Oop, fence. So you have n equals negative 4 and n equals negative 4. You have two of the exact same solutions. So you technically don't have two roots. You have one. And that one root is negative 4. So that's why you could do either way. This method, this is going to help us for a little bit later for one of our other methods on how to solve. Or you can do it this way. I don't care. But you may have noticed that n squared plus 8n plus 16 equals 0. That's already a perfect square trinomial. And when we factor a perfect square trinomial, we get a square of a binomial. But if you didn't want to do the square root business, just write it out. Okay. So what does that mean for your parabola? Well, if these guys are called roots, x-intercepts, where the parabola crosses the x-axis, and there's only one number. This is where I wish you guys were here with me. Okay? Two solutions, whatever this number is and whatever that number is. Okay? So if there's only one solution, which is negative 4, so it's over here at negative 4, is my parabola actually crossing? Well, it can't if there's only one solution. So if it's only one solution, what that means is the parabola is touching the x-axis. One solution, it touches, which means this is also your axis of symmetry. So there's that. Okay. So if you end up getting a perfect square trinomial and you factor it and you get the square of a binomial, you're going to have one solution, which means your parabola touches. It does not cross. It just touches it. And it can either open up or it can open down. But you only get one solution when your polynomial that you're factoring is a perfect square trinomial. That's it. Okay. So when you solve a quadratic, you're looking for its solutions. You're looking for the one number, like this case, or the two numbers that make the equation true. Because if I plugged both those numbers in for x that I got, I would have a true statement, meaning the left would equal the right-hand side. I should have done that with one of your other problems. I didn't think about that. It happens. Also, as long as you can factor an equation, you can also graph it, which that's what's coming when I get back. So you can see where factoring is going, because factoring here, especially like if we Let's just go. I gotta think of something off the top of my head. I'm drawing blanks. Oh my goodness. So, let's say we had to do this one, right? Well, we factor it, okay? But on Monday, we can actually graph this. I don't want to graph this if I don't have to. So you're gonna end up factoring before you graph. So that's why I have to do this one first, and that's why I made the mistake, and I'm glad I caught it, because Monday would have made no sense if I would have done this afterwards. You wouldn't have seen the connection. So, anyways, that is 7.5, solving quadratics by factoring. What that means is you gotta factor it if it's in standard form, set both polynomials equal to 0, balance and solve. So it's either gonna be a 1-step or a 2-step, not too much work. And so if you get the perfect square trinomial, pardon me, it's your choice if you want to solve it by taking the square root, or if you want to set both equal to 0, because you're just going to get 2 of the same binomials. That's your call. Okay. So sorry about the 2 videos again. That's not my fault. And I hope you guys have a great day. Toodaloo. Have a great weekend. Bye. One more week till spring break. One more. We can do it.